Hello, it's Malcolm here, and in this little screencast I'm going to show you how we use GeoGebra to investigate the conjecture that reflections reserve distances. So if you're new to GeoGebra, let me just quickly show you the interface here. When you first open up, it has an algebra window and a graphics window. We can get other windows to show up via the view. There's a whole lot of different things there, but we won't go through those just for the minute. We don't even need the algebra view in this case, but I will leave it there just because it comes in handy. Over in the graphics view, I have grids which I can turn on and off, and the axes which I can turn on and off. So given that we don't need the axis here, I'll just turn that one off. Now, up here I have a whole lot of buttons, and each of these buttons gives us something different. So this first button tells us how to draw points. So for example, if I click on that, then I can get a point here and a point there just by clicking. That's cool. You can see over in the algebra window, even though we don't need it here, that A has, the first point I have has coordinates -1, 2, and the second point has coordinates 3, 4. If I wanted to, I could actually put the labels on these things. So let me go back to select, and I select the first point, and down here I can actually say, oh look, put the name up there, and put the name of this one. I click on point B, I can put the name of that there as well, and I can shift those around. So I can draw points, I can draw lines. This one here is the lines. If you click on the little thing there, you can get all sorts of different lines. So a line, an interval, a ray, and so forth. Here I can get perpendicular lines, parallel lines, and so forth. So polygons, circles, ellipses. Here I can measure things. Here I can reflect and rotate. Here I can put all sorts of different other things on my graphics screen. So even some action buttons there. And finally I can zoom in and zoom out. So that's basically everything we can do. Now I want to check out reflections in a line, so I better draw a line. So I come down here and I'll select line, and it says to draw the line select 2 points. So I'll select point A and I shall select point B, and there's my line. Being a dynamic system, I can move those points around, and of course the line moves. They don't have to stick on the grid, but anywhere like that, so I can move those around. Now I want to look at the distance between 2 points, so let's put 2 more points on the graphics screen. Now here, it probably would be nice if these things actually had labels. So in here you can see that point is highlighted, and if I just right click here, it says show the label. So I do that, and that's point D. There we go, and this one, click on that and show its label points. Oh, I actually hid the point. Let me come over here, I can bring it back again just by clicking there. There it is. Now right click and show the label this time, so there's C. Now, I want to measure the distance between C and D. I can do that 2 ways. I can either draw a segment between C and D, and its distance will come up over here. Let me do that. So I'll draw an interval between C and D. There it is. And over here it says that segment is of length 2.24. Or alternatively, I can come down here to the measure and click measure. You look down here, distance or length. And when I do that, if I click on C and D, then there's the distance from C to D, 2.24. So there we go, we've got that sitting nicely. Now I want to reflect these things in the line. So I come to my transformations button here, and the one that's highlighted is reflect object in a line. So that's the one I'm going to use, reflect object in a line. So I'm going to reflect. Now if I come back up here, it says to select object to reflect, select the object, then select the line. So I'll select point C and reflect it in line that we have, and do the same for D. Select D and the line, and there's its reflection. And again, being dynamic, I can move this line around, and you can see that the reflections will move. Alternatively, I can move C or D, and you can see the images move. Now, what I want to check out is what's the distance from C' to D'. So let's come down here and measure the distance from C' to D'. and C dash, whoops, come back here and move. So I have to put it, I see I'm limited where I can put that. So there it is. See, it's the same anyway as 2 point, it's the same as CD there at the moment. Will it always be that case? Well, let's have a look. As we move around, it looks like those distances are always going to be the same as I move that around. Likewise, if I move the line around in there, you can see the distance from C to D is 1.58, the distance from C dash to D dash, 1.58. So it appears, according to this, that reflections do indeed preserve distances, i.e. the distances between 2 points will be the same after you reflect those 2 points as they were before. So that's all we need to see for GeoGebra for the minute, and I'll leave it there. Thank you.